class, okay, we have gone through 2 days for this short course. So now we already come to the course summary. Okay, I will recall back our course learning outcomes. So we have 3 course learning outcomes. Okay, the first one is to describe the basic of the digital system, FPGA based design, introduce modeling style and test match. Okay, can I ask you a few questions? Okay, how many modeling style you have learned?
Three.
3. Okay, good. Okay, you can name it. Structure. We have. Okay, very good. Okay, can you give some keyword only? For example, structural modeling. What the keywords? It is the keyword insertion. Okay, okay, very good. Insertion. Alright, you insert the model. Okay, structural. Data flow modeling. The keyword. Assign. Very good. Assign. Assign keyword, and it is same like the Boolean expression. The behavioral modeling, always block. Okay, very good. So always block, and it is similar for the algorithmic manner. Like you have the if else, you have the case. Okay, so that will be in the behavioral modeling. Okay. Number 2, the course line is the design combinational circuit using Verilog code. So we have covered a few things in here. For example, how you want to design the multiplexer, how you can design the decoder, okay, how you can design the BCD 7 segment with your activities that we have done, okay, until today. Okay, so my next question, okay, how many modeling can be used for combinational circuit? All models, right? All modeling, right? Okay. So this is different for the another sequential circuit. So if you want to design a combinational, then you can use any model, okay? But it depends which one that appropriate, okay? Which one that will be give the easier way. Okay, for example, you want to design a 7 segment display. It is better to use the case. Okay, case construct. Right? So means that you will use always block. Okay. Okay, if you want to design multiplex, for example. Okay, so for 2 to 1 multiplexer, smaller size, okay. If you use data flow modeling, but if it is the size bigger, then the case statement is the suitable one. Okay. The full adder, the arithmetic, the addition, right? It's better to use the data flow modeling, okay, instead of the structural modeling. Okay. So you already seen that through these courses, today's courses. Okay, number 3 is CLO. CLO3 is to utilize the parameterization and scalable model for flexibly designing little circuit. Okay, so our objective for designing is to reuse the module. Okay, so when you want to use a model, the parameterization actually the way that you can use. Okay, so you can easily change the value or the big number. Okay, for example, you want to change the adder. Okay, what we did there, we want to change the adder, the bit of adder. Just use the parameterization, just change the value only for the value in here. Okay, so that becomes the flexibility. Okay. As long for these 2 courses, okay, until today we have 4 modules already being covered, okay, which is the course overview, which is talk about the flow of the design, okay, and then the tools that can be used, okay, and then the structure of the large digital circuit, okay, so we already cover in here. And the way you want to design, okay, so Now when you go to these courses, means that you have another way to design. Instead of using the schematic, you can use the hardware description languages. Alright. So in the M2, the module 2, we go straightly for the Verilog, introduction to Verilog. Okay, what you can see in here, that Verilog, can you present back what you learn in the basis of Verilog? The module declaration, okay, the module declaration, number, yeah, right, the number system, okay, modeling, right, okay, the modeling style, the model, okay, style, okay, the parameterization lah, okay, that one, okay, the parameterization features, alright, okay, very good, okay, so. And then module 3 is the model and combinational logic. Okay, so we have covered a few things there. The combinational circuit. And then module 4 is the parameterization, scalable module, and also the test benches. So test benches is used for validation. Alright, so now you code, okay, your value, okay, to verify the your design. Okay. So just go through back. Okay, module 1, what we talk is about the digital abstraction, the digital design flow. What is the HDL? Okay, so HDL can be consist of the two languages, which is the VHDL and the Verilog. But now we move on to the Verilog because Verilog is much more easier. Okay? Then we go to the tool. Okay, so I can see the tool, some of you can use the tool like the Vivado, Quartus, and some of you use the EDA Playground. Okay, so you can have many tools that can be used. Okay, so EDA Playground is the cloud-based tool. Okay, so I can revise again. So there will be the trade-off between the tools. Okay, so like cloud-based tool. Okay, EDA Playground, you do not need to install in your computer. You just need the internet only. So then you can run or implement it anywhere, anytime. Okay, and then it is easy for designing because you can have two layouts there. Okay, two layout there, and then you also can sharing. Okay, your design to anyone, or for example, you do the group discussion. Okay, so easy to use the EDA Playground because you can share only the link. Okay, and anyone can give the comment there. Okay, so that's the one tool. However, this cloud-based tool doesn't have the library. Okay, so you cannot reuse something there. So that will be covered by the tool like the Vivado or Quartus. Okay, so if you need the library, then better to use the that tool, but you need to install in your computer. Another one, it will consume the memory, of course, okay, and it doesn't have the two layouts. Okay, so the visibility is less, okay, than the cloud-based tool. Okay, however, if you want to proceed to the hardware, then you need this tool, CAD tool. Alright. Okay, in the module 2, we go basic of the Verilog. Okay, like what you said. So we have the module declaration. Okay, how to declare the input/output, how to declare the behavior of the model. Okay, so you can use many modeling there. Okay, and then you have the Verilog construct, like how to declare the numbers. Okay, how to declare the operators. Okay, inside the Verilog. So you have a lot of operators in the Verilog. So which can easier, okay, your design, right? And then we already go through modeling style, like you said, 3 models there, actually 4. Okay, actually 4. 3 models, big 3 models. Structure have 2, gate and module, data flow and the behavior. Okay, so we can see 3 modules, but actually 4 modules there, 4 model, and each of these modeling have its own unique style. Okay, so and you need to choose which one that's suitable for your design. Okay, module 3, we already gone through the combinational circuit. So combinational circuit is just normal circuit, which is the without the clock, circuit without the memory. So means that your output depends your present input. Okay, so for example, multiplexer, okay, decoder, okay, and then you already know to use the procedure and concurrent statements there. Okay, and then also you already have modeling the arithmetic. Okay, you already modeling the RCA, the full adder, the ripple carry adder, okay, and so on. And module 4 is to make your design more flexible. Okay, more flexible to reuse the module. So then you already learn how to use the parameterization, scalable, and how to verify your design. Okay, which is use the test bench there. Okay. Okay, so based on all these of the activities that you have done, and also some quizzes that we have done, okay, here. So the submission of all the course activities, okay, the quizzes, the assignment that given for you must be done in, and also the project must be done in 2 months. So we give you 8 weeks after this course ended, okay, for you to finish and submit, okay, all the works. Okay, certification of the completion will be sent to participant within 2 weeks. So once you already submit all the activities, okay, we will proceed with the certificate, okay, for these 2 short course, 2 days short course, within 2 weeks. Okay, so competency certificate will be awarded, okay, after all the assessment have been graded there. So example in 3 months time, okay. Okay, so we have reached to the end of this course, okay, today. So now I want you to give your reflections, okay, regarding these 2 days short course that you have gone through, okay, to the pedagog. So you can write your reflection, okay, regarding the content you learn, regarding the knowledge, okay, the gained knowledge. So what you expected in the beginning of the this course, in the first day. So how you feel now? Is it achieved or not? Okay, your objective. So I give you around 10 minutes, okay, for you, okay, to write your reflection. Okay, you can write in the point. After that, you can verbal explain back to the class. Okay, for example, how you feel after these classes, your design skill in Webinar, or your ambition to do mini project in the hardware, or you want to go to competition, something competition design, okay, within the knowledge that you have gained. Okay, maybe I can call you, come here and just explain back what you provided there, or summarize back, okay, your reflection. Okay, who want to comes first? Maybe Wenjian, okay? Wenjian very long. So she want to talk a lot. Okay, so you just come here and then just explain them.
So, for my reflection is actually during these 2 days course, I've learned how to apply the behavior modeling. Then you can identify which case, like for some complicated task, and we can use the case method to simplify the task, like the BCD77. We can use a case to describe it to become more clear and easier for us.
I see. Okay, how about the data flow modeling and search for modeling?
So for the
Is it okay for you? Because you learn,
yeah,
it is
so
like
that
you,
one is more suitable for some addition or subtraction
okay.
to describe the behavior of the games.
Okay, you mean the for normal combinational statement. Okay, alright. So that one okay for you? Is that the data flow and search flow is already you well known? I mean you're okay. So now these causes help you to deepen in the behavioral modeling.
Yes, and
Okay.
then I can identify when can us to use different kind of method to deal with different tasks.
Different kind of
Become
method.
more clear to know when
I
to
see.
use the modeling stuff.
Okay, alright, okay.
So then I also learned how to use test bench to verify our design code.
Alright.
So that one I haven't learned before. Yeah, so this one is very good for me to try the little project later.
I see. Okay.
I think that's all.
Alright, I think more then.
I think I covered already.
Cover
Yeah.
already. Alright. Okay. Alright, thank you, Alicia. Okay, so you look for the okay. How about the activities? You think you feel the will help you?
Yeah, the activity is very helpful because after each session we have one activity to explain our knowledge.
Alright. Okay. To verify the knowledge of practical theories, alright? Okay, so next we want to maybe Muhammad Hakimi, alright?
Okay, for me overall, for this short course in 2 days, basically as I mentioned, this basically helped me a lot into the concept of web design, mainly refresh back what I learned during my undergraduate. Because
Alright.
if I'm going to be honest, during my undergraduate, there is a blur line between combinational circuit and sequential circuit.
I see.
Because whenever people say to me, okay, what is the difference in sequential and combinational circuit? One have always, both have always, but one have always with clock.
I
If
see.
there is a clock, that is sequential.
I see.
Okay, so basically it made me understand truly on what is the difference between it. I learned it first time, but there's still a gray area about what is structure and data flow, and I know when to use it, let's say in project, but during actual application, I just use what I'm confident with, but I didn't know that, oh, sometimes you can just structure or data flow is much better. So sometimes that blue line, for these 2 courses, it helped me a lot because it refreshed back what I learned. Probably I didn't go to class during UD, I don't know.
Alright.
So, and then the other part is, I think there is, because I'm familiar with C and Arduino,
I see.
more on the software side. there is it's quite good to understand what actually happened during my C code. When I read the C code, what actually happened to the memory. Like for instance, when we learn about adder, yes, in reality, yes, you add two number, but in real life there is a hardware that translates. Okay, when adding, what actually happened. So actually, from this course, I learned one of the most basic is the adder activity tool that we do. Basically, that helped me a lot to try to understand even more about something that I've been doing for the past 10 years. I think that is all for me.
Okay. So if I ask question, so now you can determine which modeling now you think
Yes.
that you can use now
Mm.
for. Okay, I noticed that you said that you are blurring when you use the behavioral modeling,
Yeah.
which has the always block,
Always go.
and then you blur between the combinational and the
And
sequential.
Only when people say what is the difference between
Oh, I
sequential
see.
and combination.
Maybe you think that when we use the always block, it only
yeah,
for sequential.
Yeah, sequential. So
I
I was like,
see,
okay. Yeah.
Yeah, okay. So means that now you know actually for combinational,
Yeah.
okay, combinational you can use
Use
all the
all the-
models,
Yes.
okay, all the modeling, but combination. But when you use the behavioral modeling, there will be a little bit different,
Yeah, different.
okay.
There is post-age,
that one for sequential.
For sequential.
Okay, so I can recall back that for the sequential, we just need the combinational only can be done with the sequential, and then but the differ between the behavior of the data the combinational is combinational doesn't have the clock in the sensitivities, okay, but the sequential you need that. Okay, so now you clear.
Yes, I clear about it. Really clear
Alright.
about it.
Okay. Okay. Alright. Thank you.
Thank you.
Okay, babe. Alright. So we can hear for the Nazmi. Nazmi also block quite a lot.
Okay. Stand over there.
Can stay there.
Okay. When I apply for this seminar, I expect that I will learn a lot from regarding of Verilog. That's what you said, how the operators and everything. And what I have learned from this seminar is that how Verilog could help us design better, design more. For example, like in my second year, we design using schematic.
I see.
But then this Verilog could help us to design more better and design with less complex.
Okay.
Means that this Verilog helps me in bridging the data system into the digital transformer. And what I achieved from this seminar is that I have learned a lot, and then I feel like there's a lot more because we have learned a lot of what is essential for the Verilog programming, and I also feel like although that although that I have learned a lot, means also I need to practice more a lot in order to get. But then this program has helped me a lot in grasping all the essential knowledge.
Okay.
Yeah. So,
Okay. So far you can you clear with the construct with the Verilog, basic Verilog.
yes.
Okay, so for example, when to use the data flow modeling, when to use the behavioral, when to use the procedural statement, okay, when to use the concurrent statement, okay. Alright. Okay, so alright, okay, thank you very much. Alright. Okay, so Nazmi put the future, future. So maybe I can ask again. Okay, so Nazmi said, why I know I still need more hands-on practice to build the confidence. Okay, moving forward, I will actively seek out more hands-on project to strengthen my skills and improve my RTL design capabilities. Alright. Okay, So that is your future, future for the that you are expecting, okay, from the course, yeah, the design. So how about Lakimi? You have the something in future
In the
you
future,
expected?
oh, I don't know, probably between analog engineer or something to do with digital.
Okay.
For some reason, even though analog is the best thing that I learned as a first thing, but first I start to understand analog.
I see.
Analog design. I start to understand about what can we do, but the problem is there is a lot of calculation for analog.
Okay.
I think I do analog or digital nanti my future probably.
Alright. Okay, so hopefully that these courses can make you achieve that, okay, to give you then enough knowledge. Okay, so Benzi, you have something in future you expected from these courses, or you want to learn something else, okay, from the courses that you expected that, I mean, for example, Nazmi said for architect design, okay.
So I think this course also very useful for design verification. So maybe I think I will.
Or you want to go further for the verification part, Alright. Because now we just use the test bench, okay? We do the verification, but as you know, the Verilog, we have another one. We call it as the system Verilog, okay? So Verilog versus system Verilog, okay? So what this course introduced is the Verilog, okay? But we know Verilog is where we wish in the design. Okay, we wish in the design. So that's why you can see a lot of modeling there. Okay, you can use a lot of modeling. You can use a lot of construct there in design. But for the Verilog, the verification is test bench. Okay, so you will use just the simple writing the test bench to just verify, just to see the expectation of the output. Okay, but system Verilog, okay, actually the design is less, okay, but it more to the verification. Okay, it will conduct a very complex verification part, okay, for system Verilog. Okay, so maybe for the future you are looking for more for the system Verilog. Okay, but it's okay because system Verilog and Verilog actually is sharing the same basis. Okay, in general sharing the same basis. Okay, so these short course actually give you the initial information, okay, knowledge, okay, that can wish you to do more or later knowledge. Right? Okay, so thank you for all for the reflections. So very beneficial reflection from you. So you give something that informative, okay, especially for the trainer, okay, to get the feedback, okay, from the training. So what you have learned, okay. So I can see that these 2 days courses already helped you to increase your skill. I'm not sure your rate of the skill now. Previously you said, some of you said 7, 8, right? Now is it 10? The rate for but I agree with the Nazmi when he said that the Verilog help him to design in easier way. Okay? Previously you use the harder way, which is the schematic. Okay? But now you can see, because the Verilog has a wish of the operations. One. Another one is the modeling. Okay, because in the schematic only one model only allowed, and for the operator only one bitwise only. That's why when I tell you, okay, if you want to do plus, want to do addition, if you use the schematic, you have to go through the what the first step you need to go? Truth table. You need to go truth table. After that, you need to derive the equation. Okay, for example, you want to design a full ladder. You need to go to truth table. A, B, C in. The C out and sum. Get the value in the truth table. After that, you need to do what? Simplify. K-map. Okay, 2 K-map for summation and C. After that, you divide the equation. The equation represent Boolean equation, which is represent the bitwise operator. Okay, so what you can do, the voice operator only the N, logic gate, N, not N, okay. That is the schematic. But when you use the operator A plus B, you use the operator plus with the one line code. But you have learned that you can use many modeling, right? You can use structural modeling, you can use the data flow, you can use the if else, you can use the behavior. Right? So you have in your mind now, okay, I can choose many options now in design. Okay, so this is I can conclude lah. Okay, from your reflection or Nazmi reflection. So means that he can highlight that. Okay, for the Hakimi, he said that boost up, okay, boost up his knowledge. Means that maybe in the UG he said missing something, okay, missing something. But these two shortcut at least can can fulfill that, okay, then can recall him back, okay, the knowledge that maybe he missing, okay, in the course. Okay, and Weng Xiang, I think she what summarize back all the details, like the content, right? The content, then she can recall back everything, like very small thing she can write. The case statement also, the case consult also she write it. So means that she very detailed. Okay, the operators there. Okay, even the construct of the Verilog also is mentioned there. So means that this is give her these two short they give her I mean the what, like macam kejutkan dia lah. Okay, I need to very detail. I need to know very detail. Maybe they missing something before. Alright, so thank you for the reflection. Okay, so actually we have another one. So you can complete the feedback form. This one, maybe 5 minutes. Okay, you can do complete. This is the actually the Google form only Google form. So let me go back. Okay, you can use the. Okay, just please complete the feedback form. Okay, for this. Just I think the question, just take the question only.